everyone. So I'm sorry to disappoint everyone who was looking forward to seeing JT talk about the Evolve project. I am not JT. So at short notice, I've been asked to fill in and talk about DDN's Lustre offerings. So I was prepared, I came here prepared to talk about more of a community stance, and this afternoon we have a Lustre session, which I'll be doing that. These materials I got very recently, and I've been cramming to sort of get familiar with them. Hopefully I'll be able to provide a bit of color, but do forgive me if there's some of the details I'm a little unfamiliar with. These are not my materials. So first of all, I want to start talking about the distinction between the WAM Cloud brand and EXASCALER. So WAM Cloud, as you may know, was the Lustre-centric startup which Intel acquired in 2012. And as part of the Lustre business moving over along with the engineering team and myself from Intel to DDN last summer, that brand name also, the ownership of that brand name transferred, and DDN decided to resurrect that brand to sort of and unify all of the Lustre development and engineering activities under that umbrella. So when we're interacting with other partners with Lustre solutions like HP or Dell, for example, and many others, we would be doing so as WAM Cloud. When we're hosting the community infrastructure, working on features for new upcoming Lustre community releases, all of that's done under the WAM Cloud umbrella. So EXASCALER is the DDN Lustre solution brand that's been established for many years, and that's continuing to be the way that the DDN Lustre solutions are branded. And so I think that DDN see synergies between having these things, having an open source community and a development community around Lustre is seen as being very important, and they want that to persevere and continue. But at the same time, creating more value around the DDN solution is obviously seen as being, one of the real motivations to bring the team over from Intel. So going into some of the details, so there is going to be, a bit more of formal announcement about timings and specifics around ISC. So this is just talking more sort of generically to give you a sense of areas of active development at DDN and how they tie into these DDN solutions. So Windows is definitely something which has use cases which it's required. If there's maybe sort of monitoring equipment which is on a closed system, including a Windows box, and we need to have a data ingest coming in with that, or maybe there's certain portion of the user population who have desktops, laptops, which run Windows and they want to access the main file system. So to sort of serve this need, we have gateways, and we have at the moment a very detailed setup configuration guide, which has a two-node HA configuration, and that's out there in the field today. We're also looking at how we can scale that up to have greater number of nodes involved in that for scalability purposes, and also how we can simplify and automate the deployment process. Small files has been not Lustre's strong suit traditionally. Data on MGT is seen as an approach to rectify that. So the idea being when you have small files, you're not getting the benefit from actually striping across OSTs, and then it actually becomes a negative effect of splitting the metadata and the data because you have the extra RPC overhead unnecessarily. So with data on MGT, there is when files are below a certain threshold, they will be stored entirely, data and metadata on the metadata server, and then using the traditional separation just for the sort of larger files. And so this had advantage in terms of the small files that you're able to, commonly people for the metadata servers will have higher performance storage, So you get advantage there. You're also saving on the RPC, so it greatly improves the performance for the small files. But also what we've seen as well is it increases the performance for the large streaming I/O as well, because you don't have the interference from, small files, interfering with more sort of large streaming I/O going through. Now this, obviously, as you're having more data, actual data being stored at the metadata levels, this does place more sort of capacity constraints on demands on your metadata server. So this is really as a complementary feature with D&E, which is our scaling of the metadata layers. And so that allows you to sort of get the best of both worlds, to get the better performance for small file I/O, but also to continue to scale as the number of files grows. So this feature was introduced in the Lustre 2.11 community release and there's been further enhancements and more development going on in 2.12. And so this will be available in the EXASCALER 5 release, which is going to be based on 2.12. And we'll be looking at, from a solution point of view, about how we make this very simple to deploy and good reference architectures to get the best experience deploying for this. And this slide is just sort of emphasizing the point here. This was some DOE analysis looking at size of files across a whole number of different file systems. And I think that the key takeaway here is they have a huge variety of sizes, and so the really you need an approach that's going to work across that whole range and not just specific subset of the file sizes. So progressive file layouts was a new feature that went into the Lustre 2.10 release, and so that's in the EXASCALER 4 release that's shipping today. So this was a change which allowed you to not have to be predefine the striping layout just as a singularity ahead of time. You actually could specify a range, and as the file size grows, it adapts the way that the file is laid out to be optimal. So this takes, the decision, you don't have to make the decision up front and find that in the long term it's a poor decision, or that the person making the decision maybe doesn't understand the constraints. You can have defaults which make sense, defined by the administrator that will give good results. And the introduction of this concept has also paved the way for other developments in Lustre with the data on MDT and also the file level redundancy. So, obviously, it goes without saying that data corruption is the worst possible thing that could happen to a file system. And, no one intentionally has data corruption, but still there is the risk that there's, a bug or some interaction between software layers, some sort of physical failure, perhaps some human interaction that can have, the effect of changing the data from what it's meant to be. So of the two types of data corruption, you have the type where there's an error message, it's a very clear indication that something has gone awry, and that gives you the opportunity to take the necessary steps. Maybe you can recover the data, but the worst possible case, at least the data is corrupt, and you take it out of your decision-making basis. But with silent data corruption, you don't have that opportunity. Things have shifted, you're unaware, and then you may end up making an incorrect decision based on this faulty data. So one of the things that's come in with the Lustre 2.12 release is a T10 PI mechanism, which allows you to sort of track and flag across all the layers as the data goes from the applications through to being stored on the disk. It gives you the ability to check at every layer to make sure that things are consistent as they should be. And so from our benchmarking, that has a very minimal effect on the performance, but gives you that greater assurance that you're not subject to silent data corruption. So on the security front, I'm going to very lightly touch on this. Sebastian, we have a detailed Lustre session this afternoon, and Sebastian will be going into some detail about security on that and some sort of practical hands-on tips about how you do security in a Lustre context. But so just to touch on a high level, we have a number of different mechanisms we can leverage to provide security depending on the particular, threat models you're looking at or whatever. And one of the things is subdirectory mounts. That's the ability to define, a given user or client can only have access to a subset of the whole file system. So you have the whole namespace with all the data in, but you've limited that individual user to just the project or subset of the system that they're actually allowed to see. Then for some of the other options, there's certain decisions we'd go through to sort of ascertain what the best fit is for you. And again, Sebastian will go into this more later. And on the audit front, this is very important with sort of certain compliance obligations that are placed, also to track after the fact. When something is suspected of gone awry, there's suspected of a breach, being able to actually go through and ascertain all the steps and what happened and who was doing what can be very important. And so these changelog audit facility that we have, is geared up to deal with that requirement. So on the monitoring front, so DDN has the Insight product, which is across its entire, the entire product range. So you can use it with EXASCALER, GridScaler, which is the GPFS solution, IME, which is sort of burst buffer type offering, and with SFA. And so you can go right down to the disk level and up to the file system level. And if you're trying to track down some, performance issue, it gives you the tools to be able to sort of drill in and find exactly what layer and isolate that issue so you can deal with it. So here I'm going to pause with, because I realize that probably very few people know what Stratagem is. So this is a policy engine that DDN is launching, and so it's previously been discussed at its project operating name of Light, so the Lustre Integrated Policy Engine, but its go-to-market brand name is going to be Stratagem. So moving on to sort of just explain about hot pools. So with this slide, it's talking specifically. This is a slide that's gearing up for deep learning, but I think that these requirements are very transferable to many, if not all, domains. So basically, you get your data in, you want to process it as quickly as possible to be able to make your decisions based on your analysis of that data. So to get it as quickly as possible, you want to have the highest performance storage. High performance storage is more expensive. So there are budgetary budgetary reasons that would not allow you to entirely rely on that. So, people are looking for a way to be able to use that just where you most need it. So for all the new data coming in, the data you really want to access, having that on the high performance storage, and having the data that you're retaining, just in case you need it, but it's not very frequently that you do, that can be moved to a lower performance, cheaper, more capacity tier. So obviously the effectiveness of this relies on having a really good mechanism to be able to quickly identify which files should be in which layer. So that's the idea with the hot pools, and so having the scanning engine and the flash pool be the default for everything coming in, and then having a HDD pool where things that are more of a cold tier would go out to. So on the first version of this that's coming out, will be coming out first, is we'll be using Stratagem to be able to quickly scan and identify what should be moved to the cold tier using an LRU type algorithm. And so anything that's older than a certain threshold will be moved out to the cold tier. And then, but it's possible to, from access, to move things back to the hot tier when that's required. And then as you know, in the subsequent versions, we'll have a fuller, more, the capability to define richer and more complex policies, exactly tailoring your usage, your requirements there. So getting into performance, so we did some performance analysis at the tail end of last year. So we were looking at, we knew that we'd be gearing up to have Lustre 212. That would be the basis of EXASCALER 5. We knew that we had some new hardware coming out. We wanted to see how well those work together. We did some initial tests and found some performance bottlenecks, and we were able to, work through those and come up with some coding changes which remove those bottlenecks and allowed us to greatly improve the performance numbers we got. So nearly all of those have already landed in the release, and we sort of obviously fast-tracked those. There is still one patch which is under review and going through some iterations at the moment, but we expect that's the track there with the LU11526. That's our issue tracking number, if you wanted to look that up. That is expected to land fairly soon. We're obviously keen to get that in and have that, landed well ahead of the EXASCALER 5 release. So anyway, I'll show you some of the numbers we got with those changes. So again, this was on before 212 came out, with some patches that are now landed, plus this one unlanded patch. And so the other thing we were looking at here was seeing, we wanted to get the difference between using a single MDS and then also seeing if we were getting a scaling boost by having, leveraging D&E and having 4 MDSs in D&E. So you can see that, can't see the exact numbers, hopefully you can see that quite well, but on your left, we have this is running MD test with unique directories, and we were getting somewhere in the mid 100,000 file creates with a single MDS. And then when we scaled that to having 4 MDS, we were getting, in excess of, 600K file creates, and then file deletes a little bit higher, there. And then on the right, we have a single shared directory, much higher initial. Oh no, my higher, it's a different scale, sorry. So like over 80K file creates, and when we introduced the D&E and the multiple metadata servers, we were able to boost that to over 120K file creates, and with the file deletes, it started off probably around 130K and went up over 160K as we scaled with the metadata servers. And then A3i is DDN's product line, which is geared at the AI machine learning market. So it doesn't generally in the marketing materials call out that Lustre is involved, but Lustre is involved. So with this, so this is showing there's two offerings, the entry level one and then a more of a premium offering. And these are all 100% NVMe. And so sort of the headline is with the AI 400, so that's the premium offering. So there was 45 gigabytes a second throughput and over 1.5 million IOPS from, and then, this is just breaking it out. These next two slides are just each individual product separately. So that's what I just said there. And then the AI 200 has slightly lower, 25 gigabytes a second at throughput, and 800K IOPS was the best numbers with the optimal file size. And then for the 18Ks, so this is the test system layout that was done with this. So this was, rather than on 212, this was actually the shipping EXASCALER 4, EXASCALER 4, which is 210 based. It does sound like, I'm not 100% sure, there may still have been that patch that's dual to land on master that also applied to get these numbers. I'm not 100% certain on that. I'm sorry, but just I was having a brief discussion with the engineer who ran the tests just a little earlier this morning, and I think that's what he was suggesting. But so the numbers here are basically showing really good scaling as the number of, if you can see the scale at the bottom, you know, we have the OSSs and the OSDs scaling with each step through. And this is running IOR with 1 megabyte file per process, and got up to 61 gigabytes a second write throughput, and 58 gigabytes a second bandwidth for the reads. Okay, and then these last slides are just pure marketing, I'm afraid. But so basically, SFA has been around a long time. It's proven to have very good performance and be very scalable. Obviously, it's the, you know, DDN has both GridScaler and EXASCALER built on SFA, and so it's very, you know, has been very widely used over a number of years. In terms of service, you know, definitely I was, you know, I'd worked with DDN as a, they were, you know, the major partner we had for some years through all the different places I've worked, right back to cluster file systems with Lustre, and so DDN were always, you know, one of our larger partners through all of, you know, Sun, Oracle, WAM Cloud, Intel. So now, you know, I was always aware that, you know, DDN had expertise, but, you know, I have, you know, now being inside DDN, and I sort of have a fuller appreciation of what it takes to have, you know, such a large field organization and a 24/7, you know, worldwide support organization, and to maintain that at that level of expertise and have that available is, you know, definitely a differentiator that DDN can offer. So, you know, why would you choose EXASCALER? So obviously DDN has a very long track record in data at scale. I think they've been going for around 20 years. Support and service, as I said, you know, has a very strong support and field capability. Performance and scale obviously is the touchstone. DDN's been very involved in top 500 sort of deployments for a long time. And then these last two, I mean, to me, seem fairly similar. These are obviously the kind of, as we've talked about before, the synergies of having the sort of greater pool of Lustre expertise in-house. Just like we were talking about earlier on about that, working with the, you know, pre-release new next generation storage and being able to very quickly have engineering attention to optimize for those platforms is, you know, obviously has great advantages, you know, to having a performance system out of the box by the time the users start getting their hands on it. So I think that's all the slides I've got. Does anyone have any questions or? Yeah, okay.